Alright, hello and welcome to a physics tutorial. So today we will be looking through problem number 43 in chapter 23, which talks about Gauss's law. So let's look through our question. So we have a large slab, it has thickness, unusually. So it has a charge density and the origin is at its center. And we want the electric field at a series of x coordinates. So let's, as usual, make a picture. So we have this, the two sides of the slab, and then the center, which is the origin. So what we want to do is draw a Gaussian surface. So here and here. So what we need to notice is that we use symmetry because the electric field goes at both sides. So something like this. Then we can use the symmetry in Gauss's law to find our electric field. So we have EA equals Q over epsilon 0. So from there we can see that EA is doubled. So we have E times A, which is A squared. So let's say that A is just some arbitrary length, a square side length. So we have 2EA squared equals 2 times the charge, which is XA, which should be, this is a distance x, which should be x a squared rho over epsilon 0, because of course Q equals rho V, and again 2 because symmetry. So we have that, which gives us basically a formula for E, which is rho x over epsilon 0. So this allows us to easily find all four answers. So at 0, x is 0, so the electric field is 0. So for B, we plug in 0.002 meters or 2 millimeters, however you like to do it. Either way, you should come to the conclusion that the electric field is 1.31 micronewtons per coulomb. So for part C, we plug in 4.7 millimeters, pretty easy, and now you get 3.08 micronewtons per coulomb. And for part D is interesting because this Gaussian surface will now be outside the slab. However, what we need to notice is that the area does not change because, of course, the area does not depend on the thickness of our Gaussian surface. And also, the charge does not change from part C because part C also encloses the entire slab. So we should see that the area doesn't change, the charge doesn't change, epsilon 0 doesn't change. So we should get that at 26 millimeters, the electric field is still 3.08 micronewtons per coulomb. Thank you for watching. I hope you learned something about complicated Gaussian surfaces. Please like the video, subscribe to the channel, and I will see you later. Bye!